Alright, so in this video we're going to look at the mechanics of breathing, kind of the physiology, if you will, of how breathing occurs, how the lungs work. And so breathing basically consists of two phases. There's inspiration, which it doesn't, this says exhalation and breathe, which is a silly picture, so that's why I liked it. But there's inspiration, this is when your gases are flowing into the lungs, and there's expiration, gases are exiting the lungs. And those two things we'll talk about separately. So first, before we talk about this, we need to talk about pressure relationships in the lungs. And so the first pressure is atmospheric pressure. And there's a lot of things going on here. You can talk about these different numbers and stuff here. But basically, we'll talk about atmospheric pressure as being one. All right. And so you're going to have something that's less than that and something that's more than that. And on the inside, you have a couple of other pressures that are going on. You have intrapleural pressure and intrapulmonary pressure. Intrapulmonary pressure is just the pressure that is in the actual alveoli, and the interpleural pressure is the pressure that's in the pleural cavity itself, which is that inside that bag, those pleura that we talked about last time. And the interpulmonary pressure will eventually equalize with the outside, but the interpleural pressure is always negative. And so if you think this is kind of hard to think about, but if there's this law, you've probably had this law in chemistry, and we'll get to this in a second with the next one here. Yeah, like Boyle's law, and Boyle's law is basically gas will take up the space that it's in. Well, if the space that it's in decreases, then what happens to the pressure in the container? Well, it increases. So those two things, volume and pressure, are inversely proportional. If the volume increases, the pressure decreases. And so the pleural pressure, the interpleural pressure, always wants to maintain this negative because it keeps the lungs inflated. If it's ever positive, it will actually press on the lungs and it can cause the lungs to collapse. And so, for instance, if fluid ever builds up in the lungs, one of the fears of fluid accumulating inside particularly in this pleural cavity, is it can actually collapse the lung because it can press on it, causing a positive pressure. And so the pleural cavity attempts to maintain a negative pressure constantly to keep the lungs inflated, to keep those, even when you're exhaling, the lungs can stay inflated and keep that pressure so that you can take another breath. Basically, what's going on there. And so, looking at this idea of pulmonary ventilation is just a really fancy word for saying breathing. But again, inspiration and expiration. The mechanical process of breathing depends upon the volume changes in the thoracic cavity. And so there are different structures in the thoracic cavity that cause the volume of that cavity to change and thus cause you to breathe in or breathe out. And that has to do with, again, with that Boyle's law. That Boyle's law is that if the pressure or if the volume goes up, the pressure goes down, and so forth. All right, hope that makes sense. And so for inspiration, if you look here at the top section of this, inspiration is an active thing. It doesn't happen passively. And the diaphragm contracts, okay? And when the diaphragm contracts, notice here, you can kind of see how this diaphragm is in here. Well, if the diaphragm contracts, it will actually flatten out, which increases the volume of the thoracic cavity. If you increase the volume, you decrease the pressure, right? And so that causes a uh, decreased pressure on the inside, which causes you to want to breathe in, right? And also, these muscles here, these intercostal muscles, also do that. They cause the pressure to be, or the volume to increase, and thus decreasing the pressure causing you to want to inhale. Now, you can inhale like a forced inhale, like the doctor, you're at the doctor and they put the stethoscope on your back and they say, take a deep breath. And when you take a deep breath, think about what you do. The first thing you do when you take a deep breath is you straighten your back up. What are you doing? You're lengthening your thoracic cavity so that you can take a deeper breath. That's a involuntary thing that we do, and so we are able to take deep breaths in, even though we don't have to think about breathing in general. And so think about expiration then. If you look at the bottom picture, expiration is mostly a passive process. Now we can forcefully exhale, but when those muscles relax, relaxing is not active. It's just a passive thing that happens. So when those muscles relax, the volume decreases, therefore the pressure inside increases. And if the pressure inside your pleural cavity or inside your thoracic cavity increases, there is an outlet for that pressure, and that is your nose and mouth, and the air goes out. Now you can forced exhale as well. Same sort of thing that goes on there. You can change the size of your thoracic cavity, make it smaller, using your abdominal muscles and different things, like when you cough. And so that there are some non-respiratory air movements, that you can that don't have anything to do with breathing necessarily, like coughing, sneezing, crying, laughing, hiccups, yawning, all those kinds of things, and those don't necessarily have to do with breathing, but the body will still use this same mechanism in order to change the thoracic cavity and therefore cause you to breathe in or breathe out.